Hey everyone, Mr. Schachter back at you with some new formulas. Let's talk about the formula for exponential growth. So the exponential growth formula is very similar to our normal formula. Remember, our normal formula is y equals ab to the x. But that's a terrible x. So we'll try that again. But in this example, or in this formula here, the b is going to be a little bit more developed. And so what it's going to look like is the growth formula is going to be y equals p parentheses 1 plus r, close parentheses, raised to the t. So notice that this kind of takes the place of the b, and we'll talk about what that means in a little bit. So what you need to know is the p stands for the principal, or the initial amount, similarly to a. The r stands for the rate of increase, and it's very important that in your formula, your rate of increase is always a decimal. So oftentimes we're going to be dealing with a percentage. You need to convert that to the decimal equivalent. Okay, you don't plug a percentage into your formula. And last, the t is the number of time periods, number of days, number of months, whatever it is that the problem is dealing with. Okay? The exponential decay formula is exactly the same, but instead of the plus in the middle, it's a minus. And these guys are still the same. You've got p as the principal, r is the rate of decay, and t is the time periods. So, one thing that we could do now is start to take a look at what the growth or decay rate is when looking at a formula. Well, let's take a look at this one. It says y equals 2 times 0.68 to the t. And the first thing you could do is understand that this is exponential decay. And the reason is because b is less than 1, but also greater than 0, all right? So remember that last video. If b is a fraction between 0 and 1, then it's exponential decay. The question is, if I were to compare this formula as it's written to my exponential decay formula, which is, we use p, which is p1 minus r to the t, the question is, what is r? What is my decay rate? Well, in order to understand this, we have to think about everything in terms of 100%. So in order for this to kind of be b, we have to ask ourselves, what would you have to add to get back to 1? What would you have to add to 0.68 to get back to 1? And the answer is 0.34, or 0.32 even, 0.32. And so you kind of say, well, if we were to write this down, we have y equals 2 times 1 minus 0.32 raised to the t. Okay? And now, as it's written, notice that it matches this formula right here. And so you can easily identify what r is. R is 0.32, which means the decay rate is 32%, the decay rate. So in order to answer these questions of growth and decay rate, you're always thinking about how do you get back to 100%. If we were at 0.68, you would need to add 0.32, and that is your rate of decay. The same thing goes with a growth problem. So let's do a growth problem. So it'd be y equals 1.05 raised to the t. Now this is growth because the value of b is greater than 1. The question is, if you were to try to think about it like this, 1 plus r raised to the t. What would this r have to be in order for this formula to equal 1.05? And the answer is simply 0.05, because y equals 1 plus 0.05 raised to the t is equal to this formula, because 1 plus 0.05 gives you 1.05. So in this problem, the growth rate would be 5%, because 0.05 would be 5%. The decimal turns into 5%. All right, so again, it's all about kind of getting back to 100%. So 1.05, how would you have to get back to 100%? You'd have to simply subtract 5 or 5% from that. The 0.05 is what your growth rate is. All right?